Kindly have a Is it visible to you, sir?
Yes, sir. Yes.
Yes, very good afternoon, Professor and Reverend Dr. Navanshu and other colleagues from subcontinent. As you have knowledge about the agro advisory till now with the competency of Dr. Navanshu, in today's lecture, he has already told you about the genesis and the future outlook and the work being done in the continent and in addition of that, I'll continue to complement the already ongoing knowledge you are having with you being domain experts. The second slide is visible to you. Okay, under this title for the operational agromet services for agriculture or climate and weather services, it's very important. We will deal with the AS framework, the product, the indices, what you have discussed about the thermal tolerance index or thermal humidity index, and then how it is being prepared and disseminated, and then what are the future through automation or AI or machine learning. The concept of this agro advisory service with we initially call it the weather-based agro advisory service or agromet advisory service, where it supports the farmer to make a decision in his field in his day-to-day basis. And nowadays we are expecting, or people are expecting, the local specific advisory, particularly for perishable crop like grapes and other horticultural vegetable crops. And it will help in reducing the risk or input efficiency increase and then enhance the yield potential or yield recovery in the field. I am being one of the first regular agro advisory scientists joined in 1991 when only five stations or AMFU were planned by the government of India after a MOU between government of India and the United States of America. On those days, Ronald Reagan was the president of US and Rajiv Gandhi was Prime Minister of India. Being a pilot, Rajiv was well aware about the meteorology, how it is important in aviation. And then prior to those, in the time of 1987 drought, it was felt that Indian agriculture needs some medium range weather forecast expertise. And for that purpose, on the lines of ECM RWF, European Center for Medium Range, a National Center for Medium Range Weather Forecast was created under DST, and the manpower, the expertise were taken from India Meteorological Department. Later on, it became a separate entity, and they did wonderful work. And then every year the AMFU goes on increasing. Earlier it was thought of about every agroclimate zone has to have one agromet field unit to advise the farmer in particular region or zone. Later on, as Dr. Navanshu told, the resolution was very refined. Then they thought of district level and the block level. And the lot of funding pumped to this, and the Indian Agro Advisory Service became an example throughout the world through WMO under the able guidance of Dr. L.S. Rathore, and under the headship or expertise of Dr. N. Navanshu and other senior colleagues who happen to be with me throughout this journey. What are the scope of advisory? It help in crop management, the day-to-day operations, how your crop is behaving based on weather parameter. You can improve or manage your crop. Then the water management is a very precious input. If water is available, you are there. Your crop is there. Otherwise, it's very tough to grow anything or to sustain anything. Then about pest and disease alerts. If you are doing your crop is doing wonders, then there are a lot of enemies in the form of pest and disease, and if you have to monitor them, and the alert are being issued through weather-based triggers. At what time, under what conditions, these are the alerts, and then you have to manage. Then later on, extreme weather preparedness, so that we can prepare for flood or some drought or some other big event, extreme weather event, so that we can save the agriculture. In India, the institutional framework regarding agro advisory service or agromet advisory service run like this. Earlier, it was IMD who prepare the forecast and do this advisory through their sister concern and agriculture department is that Indian Council of Agriculture Research. Then all SAUs and at every provincial level or the state level, and then various ICR institute also have some advisory system or setup. Then AMFU under every SAU, then after refinement of resolution of forecast, then they have DAMUs, the district agromet units, then under which the various Krishi Vigyan Kendra, we call it Krishi Agriculture Scientific Science Centers. In this way, this framework work from top to down, then goes to the ultimately has to be passed on the same day to the farmer. The operational workflow of advisory, first we have to have weather observations, various parameters, mostly 6 parameters we have to take observation, and under all MFU is a mandate of IMD to have at least one observatory in that agroclimatic zone. Then IMD or NCMRW has to prepare a forecast for the region for 6 days, 7 days, 5 days, and then outlook also. Then the expert available in the field, in the KVKs or Department of Agriculture, they give the feedback, the reporting about crop conditions, under what condition your crop is there, at what level, what's the phenology, what is any attack of insect pest or any sort of assessment they provide. Then a team of experts, domain experts in agriculture, from pathology, entomology, nematology, soil scientists, economists, horticulture, vegetables, and all agriculture engineers, agronomists, they all has to sit together, and this meeting is being coordinated by a agrometeorologist, because he has to say that this is the likelihood of forecast for this zone or this station for next 5 days or next 7 days, and this will be the outlook. And then he has input from the field that this is the situation of the crop. Then every expert give his input. Yes, under these conditions, this is our likelihood of any insect or disease or some stress of moisture or some fertilizer issue or likewise. And under those conditions, they also give remedies, the application of any fungicide or weedicide or pesticide. And after consensus arrived about the advisory, because advisory has to be in a 1 page or so that it may be crispy and very easily available or to be adaptable by the actionable by the farmers. After that, this advisory has to be disseminated at once without losing time. In early 90s, it was very tough for us to prepare advisory to get the forecast at 11 a.m., then to prepare this advisory bulletin by 3 p.m. Then we have to run for the press or to get it published. But by that time, the newspaper has blocked their or used their columns, so it may become next day, and some fineness of the bulletin may be lost in the but nowadays we have automation, we have a lot of communication system, and we can disseminate in no time for different temporal scale. We have the advisory on daily basis, weekly basis, fortnightly by the national hydrological meteorological agencies. Some private agencies are also working, even some global or regional big companies are also providing these uh, temporal weather advisories. And government of India, the IMD also issue some monthly outlook for a parameter like rainfall or temperature mostly. Then we have seasonal forecast in the region. Most important, our well established monsoon season. Generally it is in the first week of April the first forecast came, and then later on in the last of May, it is second forecast come for the region. It includes all subcontinental region including India. And in this way, this temporal scale, this agro advisory follows. The key agromet parameter we usually received from day one since 90, the project was started in India in the name of experimental agro advisory services. And now it is GKMS, Gramin, related to rural areas. They have rainfall in millimeter, temperature in deviation degree Celsius, relative humidity, wind speed, wind direction, and cloud cover. And on those parameter, the actual values are being uh, defined at today what will be the date and how the temperature or rainfall the possibility are there. The next day what will be the humidity, the direction. And in this way quantitative forecast is being prepared at the AMFU level, and then that has to be disseminated in the same format, because the format is being developed by the India Meteorological Department. And while preparing agro advisory, as we have discussed about the data collection, the forecast analysis, recommendations, and the forecast analysis, if you have some digital forecast, but your ground reality, you being observer or expert or coordinator in the MFU, you have to take the local conditions also, and you have to refine the forecast provided by the stakeholders or IMD or your national meteorology or hydrology agency. So you have to add values in the forecast so that it may be true to type, and may under these conditions what your recommendation, whether your recommendations are actionable. You have to be farmer friendly while recommending your advisories. And this is the format. Here in the table you have all agromet parameters, and then in the next table you have crops or the livestock and the status and what sort of advisory you are. And it is to be generally one page so that the farmer can easily if you make more than one page, then it loses its crispness and formal. It is being likely to be ignored at many places. Then later on, we have to have under the outreach program under AAS and other ISRO or Space Application Center Ahmedabad. They have started some soil moisture and temperature product, because earlier 6 products are being observed by the simple standard agromet observatories. And but these realize and soil moisture or soil temperature for a particular reason, and the anomalies they are supposed to be determined by the indices developed for the purpose and using satellite technologies. And then we have, because water requirement, the irrigation scheduling, the use of efficient use of water or water use efficiency enhancement, the network of evaporation is very much important, because it's a very in high number. The India Meteorological Department has very large network of evaporation stations. Even they have only lysimeter or evaporation data weather. Even they don't have the standard meteorological observatory. So this data help in providing the realistic probability of the atmospheric demand of water or the crop requirement, or the water available for the irrigation, and so that the necessary arrangement may be done at the government level or the at state level. Generally we have to deal with. And then later on they started the temperature humidity index, because the farmer have their also have, other than crops, they have their animals, their poultry, their fisheries. And for that comfort, there is a one index known as temperature humidity index, where you can feel like that if you have a temperature of 40, but due to high temperature it feel like 45, and you will be, or your product or your bio entity may be under stress or under uncomfortable. So it's a well established indices throughout the globe prepared for. And to monitor productivity also, then this section of advices also introduced in the Agromet advisory services. Likewise, in heat unit, it's all operational use of Agromet services in agriculture. The heat unit or cold unit, because everyone needs energy, and every biological entity or crops or men or animals, livestock, poultry, they need certain amount of energy to have the next action. Likewise, in crops, to start from sowing of seed to germination, then to coleoptile development, and then to establishment of seedling, then various stages it needs some energy. If that if on your station, if that particular energy known as growing degree days or thermal unit using base temperature, then if that amount of heat unit or energy summation is provided to particular crop, then enhance its efficiency, but it may affect or deteriorate their later development in the crop and growth system. So for that purpose, your energy should be fairly distributed, so that a plant can attain every stage of growth and development, and so that the final yield may be very good or very efficient. Likewise, in polar regions where chilling requirement are required, chilling hours are needed to sprout, to have flowers, certain amount of chilled hours are required, like in Himalayas, sub-Himalayas. And then using both of these energy availability, because it's one of the simplest form to predict the crop growth. If you have certain amount of energy or temperature values, in summer we usually have 10 degrees Celsius as base temperature, and in winter we have 5 degree. Otherwise, every region, every crop has certain amount of base temperature. When we average the temperature and subtract the base temperature, that is the energy unit available of particular day for that crop. And if your any crop grow in 100 degree Celsius energy unit, then in how many days this can be attained? This is very good concept for introducing new variety or new crop in your region on the basis of availability of agroclimate resources, we call them, whether availability of energy in a particular region, energy or radiation availability or rainfall normality. All these help in introduction of new crops or prediction of crop growth stages, and later on the final yield. Later on, with the supplementation of various high-tech inputs, we can calculate the yield in very accurately. Then, as Dr. Navansu has already told about the dissemination challenge, so many SMS services, mobile app, lot of mobile, every SAUs or Central Agriculture Institute have been assigned to produce their own mobile app for the purpose, so that their regional farmers can have their advisory through these apps. But these have a limitation. SMS has limitation because SMS is being used in emergency. You can't have all whole one page advisory through SMS. Likewise, mobile also app you upload, but you can't translate as per the requirement or actionability of the farmer. And WhatsApp group also, every nodal officer or the expert, they have their own group to the, but this also have limitation of group dissemination. Yes, the radio, TV, these are very much in demand because they exclusive or dedicated radio station who works for farming community throughout the day or the dedicated hours, then they are very useful to provide the all advisories. And then farmers meeting to ask them to meet in a particular village under KVK system, and so that they can see what the crop condition, how it is being done, what how to they have to judge their crops, some action to be required, whether some surprise needed, and in this way awareness program is also being, and all these through various ministries being disseminated various very good or expertise way of dissemination. Then we have discussed in the last lecture also about drought indices, because later on when the drought is a very serious issue throughout the globe, because if you have a flood in your region, you are likely to lose only one season of your crop, and the rest of the 5 or 6 year you are likely to have a FD, like in banking system, you are recharging of your soil, so that in the later on through pumps, and you can have good amount of water in a very low energy consumption. But if you are under drought your system, then you are likely to lose every day slowly and slowly, and it is very detrimental, as that Navasu shown about 1877 or some drought like situation. And that is very critical for this information provided for this extreme conditions. So various indices being calculating using availability of parameters, and on in WMO also they have dedicated program IDMP and the expert team on drought, with which I am associated on behalf of Asian region. And this is being one of the important concept in the agriculture system. So that's why they have given a very strong weightage for this purpose. Then type of drought you might be well about, meteorological drought, agriculture drought, hydrological drought, and socio-economical drought, depending upon the situation for under what condition you are using these terminologies. Then crop water stress index, some new instrumentation like some infrared thermometry, where you can have difference of air temperature and crop canopy temperature. And if they are in negative, then the crop is under stress, then you can go for irrigation, or you can have some automation so that it can start some automatic triggers, and so that your uh, uh, tubewell facility or irrigation facility or fertigation facility may start, and is a part of automation also. Then we have heat stress under heat conditions. What sort of advisory they are being issued by the various agencies, and how to save your plants. It's very tough rather to save plants under heat stress. You know, many times you have heard about terminal stress in North India, where in the fag end of reproductive phase, rather in March, early March or so, the temperature rise above 5 or 6, above normal, and the crops which are likely to be under a high reproductive stage, where the grains are supposed to have good size, but due to the terminal stress, lot of uh, uh, decrease may be reported around 20 or 25% due to small size grain, due to forced maturity. These size of grains may be very low. For that purpose, there are some chemicals or some fertilizers for foliar application are being devised, because irrigation at that stage is not so much available. Then we have cold and frost. We also have this frost injury. The plants have some inbuilt system to face the frost or cold injury for 1 or 2 days. But if it becomes continue, then we have to save these plants. They become black because the whole their arteries or whatsoever the pipeline of their system, they become freezed, and there is no movement of nutrients or water, and they become black and die down. For them to continue, just like our heart system, it operates in these conditions. They're opening through stomatal opening, and there's some physiological movement of water or the nutrients is not there, and that's why we have to apply some water with, because water has some highest specific heat, and it takes time to become cold or to become hot, and it maintain a regulation, a microclimate improvement. That's why water or some sort of some areas small smoking is being done to make the ambient temperature normal, to arrest the frost injury or the cold injuries. Then nowadays, due to very high intensive development through roads, network, not in every nook or corner you have national highways or big factories in rural areas, big industries. The air become pollutant, and many times when you cross over through a highway, you see the crops are not so shining, all due to because there is some vehicular pollution, some dust pollution is there, and the crop are full of them. And this is the side effect of this intensive development, where the agriculture has to pay a big price. Uh, then public service also, because if everyone is being aware, then only we can expect that your services are in right track. The climate literacy, every must have the nature, how it is being affected, what is climate, what is weather, and what are the season. Because nowadays the newer generation want everything in every day, whether it's of any season of the crop or the fruit, or but it's very tough to grow off season, the to grow any vegetable or crop or fruit in a glass house or greenhouse, because it needs a lot of comfort for that crop to maintain the convenient temperature or humidity, and the respect also improve, because the production cost is very high. If you have seasonal uh, stuff, your production cost is low and you are near to nature. But for that, we have to have these program, this farmer awareness, literacy program, citizen science also. Everyone must be a scientist, a citizen. What sort of he is observing about clouds or about some abnormal trend in the weather parameter. He has to, even IMD has started a page to upload any photo by any citizen. Yes, if you are seeing some unusual parameter of climate, you can upload there, and it will help in forecasting or to see the pattern of your advisory or production. You all know why we crop advisory is being used, because it helps in crop production. Because if we say that the time has come for monsoon or is likely to have rains, or after 3 or 4 days, then you have to go for land preparation to manage your implements or some machinery for the land preparation, because in India also very large chunk of farmers are marginal farmer. They have to depend either on some customer hiring centers, or they have to lend the machinery from some bigger farmer. So for that purpose, that's why this medium range has objective, because if you have only 3 days forecast, which is more accurate, a farmer cannot manage his resources to make your advisory actionable. That's why the medium range came into existence, and it's at least 7 or 10 days in advance. He can lend, he can borrow, he can do something to save if your forecast is acceptable mode or near to acceptable, then he can uh, do good for his crop and ultimately his survival. Then sowing and transplanting also is very important. If a right time sowing based on the likelihood of monsoon or some sowing rains. Likewise, harvest scheduling when MSP, anytime some crop price is fixed, then if you have earlier harvesting due to some reason, it is you are not likely to get the remunerative price. That's why you have to have schedule accordingly, but is have some limitation, because the farmer don't have enough space to save his harvested product. For but he has to depend, if he has harvested, he has stress, then he has to go to the market, and if rates are good enough, is okay. If the rates are as per the uh, glut in the market or the shortage in the market, is likely to face the music in this way. Then irrigation and input management, very important. The most of the cost of a farmer goes through this irrigation and input management. This at what time the irrigation required. Many times we have a good forecast. Yes, monsoon is likely in the next 4 days. Then farmer also have land his water for irrigation. Then if he is sure, yes, forecast is okay, then he can leave the irrigation, hired irrigation, so that he can save this amount of penny for the accurate forecasting. Fertilizer application also, if he has labor management, pesticide separate, all these depends upon these accurate forecasts, which are very much realistic and actionable. Then extreme weather advisory, as Dr. Navans was told about how heat wave, cold wave advisories, and this cyclone alert. Cyclone, you might be well aware about India's success in cyclone forecasting in the region. One of the best tracker in cyclone forecasting, and these are also being very rightly forecasted and well taken by the whole government of India, various department, district administration, state government agency, even at international level, International Red Cross and subcontinental government, they help each other to track the cyclones also. Even under these conditions, some fishermen take risks to venture in the deep sea under cyclone, so that they can have very bigger fish, so that they can enjoy the product for a longer time. but they are at risk because to under cyclone, the human risk is more important than their business. So these are very well established services by Government of India. And then we have livestock, poultry and fishery advisory for their comfort under heat, under cold, or under some feed issue, or in some aeration, because in many inland fisheries, many times lot of fish are dead due to aeration issues, and it is being monitored regularly by the team of experts whether the pond has enough aeration to for fish to survive, to take breathe. And in this way, this advisory or this service is being appreciated by one and all. Then operational pest and disease forecasting also. Because it's a trigger based, every crop or have some certain type of insect, and every insect or disease have certain type of weather parameter at which they start progressing, and on those basis we can advise the farmers, yes, this is the temperature congenial for this type of disease or pest outbreak, then go for this sort of application, some fungicide or insecticide, and in this way you can have your good crop in the field. Then automation is required to make the advisory available within a click of button. For that, you have a good network of automatic weather station, because well network, even under mission Mosam, Government of India has started more and more AWS installation. Then we have forecast models, then having AI and machine learning, then satellite data input integration, and then finally on the basis of this data we can have a automated AAS. But still the man, the nodal officer, the expert who is in the middle of the system is the key to make it happen in on real ground. Then we have integrated digital advisory platform, because we can't go by station or by person to person. We have to put all these advisories at a certain platform so that every stakeholder or the attached person may have access to that particular platform to use the advisory available. For that, we have to observation network, as already discussed, the forecast for every small level at based on the resolution available. Then the what type of indices we have, like crop weather calendar, as that Navansu told about the various crop calendar, at what time one has to grow and what time, what type of insect is coming, irrigation, and this way the calendar, then satellite data, how it sees from the sky, the crop conditions, and then real-time decision support. Then after having all these in one platform, what will be the real-time decision? What farmer has to do for particular region, and this become an integrated digital advisory platform. After experimental agro advisory service, it became integrated advisory services. Then in between, they came with the economic impact of agro advisory service. Then it became GKM as Gramin Krishi Vikas Seva. Then it became block level, Damu district level, and depending upon the manpower or the interest or the push from person like Nabansu and Dr. Lathor, we achieved a lot of uh, good things in this. Then future of agro advisory. We must have smart villages where a village have everything like automation type of facilities. With a click of button, it has all facility, information, awareness, advisories, input available for action. And these are the future under agro advisory. Then, as discussed in the last slide, AI driven advisories where every component from sky to below earth be incorporated in the advisory, and it's a comprehensive advisory. Then become a personalized farmer weather service, because if you are a big farmer and you have a orchard to have grapes, then you will ask for advisory for your grapes. That has to be provided. Yes, for your farm, this much of your acres of grapes are there at this stage. For that purpose, under these circumstances or weather conditions, you have to do these operations. So these are some personal. Also, where in summary, we have covered this operational network framework, product and monitoring data, and digital transformation. Recently, we had a book on operational agrometallurgy with my senior colleague, Professor B.V. Ramana Rao. You might have heard him, the very enthusiastic old horse, the founder PC of Agromet project, and then my even PhD or master's advisor, Professor Mishra. We had a lot of books written, and one of among them is the operational agrimetallurgy of forward, which written by the former chief agrimetallurgy of WMO, by Robert Stefanski, and that has to be dedicated to a person who did wonderful work in agro advisory in the farmer fields. So if you wish, if you have want to have this in your library or your department, you can purchase from NIPA through this their web portal, and we are open to discussion as and when time permits. When Dr. Navasu will ask us to. With this, I commend my lecture. Thank you. Thank you very much. Thank you, sir. I'll be there.
Okay, sir. Thank you. Uh, just I'm sharing my screen to. Yeah. Uh, a very good afternoon, everyone. Respected Chattopadhyay sir, Dr. Surendra Singh sir, and my fellows from different continents, different countries, including India, who have joined this session. This is very difficult to talk after renowned persons like Chattopadhyay sir and Dr. Surendra, who was working internationally. Uh, but I will try to express myself before you, sir. So my talk is Agromet Advisory Services and Climate Information for Operational Advisory. Here, uh, most of the things has been covered by our previous speakers. So I will try to skip those things for the repetition and what is new and how we have worked. Some case studies will be discussed with the floor. So our talk will be mainly on the introduction of the Agromet services, where I was worked for at least 10 years in the southwestern region of the Punjab under Punjab Agricultural University, my prior institution. I will discuss on the importance of agriculture for India, Indian people, and climate and weather related services. Risk and challenges in agriculture, mainly deadlines and climate or weather related challenges. Climate change, hotspots and scenarios. We will try to explore the risk and vulnerability maps and impact of climate change on economy, hydrology, agriculture, and horticultural sectors. Maybe will be covered. And a case study of the recent climate data analysis of India Meteorological Department from 1901 to 2025. I will talk on this. Then the agrometeorological advisory services under the Gramin Krishi Mausam Seva scheme will be talked. So lots of information are available for the climate and integration of the agrometeorological systems with the long-term climate information or the generation of location-specific reliable advisories and actionable decision support system uh, is need of the hour. Just 1 minute. It is covering my slide. So I'm putting it here. Yes. Yeah. Because integration of real-time agrometeorological advisories well informed with the long-term climate decision, climate informations will be more helpful to develop the specific location specific operational advisories. It will improve the quality of advisories in making better decision, reduce climate related risk. It will increase the productivity and profitability because at the same time it will develop the resilience on the climate resources and agriculture systems. Agriculture is very important sector for India and the world because it provides food and feed and fodder for the human and livestock, contributes nearly 14% in the India's total GDP. That is about 51% higher than that was in the 1950 to 1955. Agriculture resource for the employment of more than 50% of the Indian population. It supplies raw materials for the textile and sugar industries. Uh, Agriculture is a source of the trade of many articles such as tea, jute, cashew nuts, tobacco, coffee, spices, etc. So, major consumer of the transport services of the country is agriculture. Our weather services are very important for different sectors such as aviation, takeoff and deciding the timing of the aviation landing and takeoff time, shipping, defense systems. Now I am also issuing the tourism forecast, monsoon, agriculture, power and energy sector is very important nowadays because it forecast based supply of the energy is being provided, then lots of the energy can be saved. Our services are also rendered to the sports are deciding the place of tournaments of many sports like football and outdoor cricket, mountaineering, cyclone monitoring, flooding, agri-heritage, fishing, hydrology, urban development, disaster response, and health. All these sectors are using the services of India Meteorological Department in IMD forecast. Nowadays, agriculture has faces lots of challenges. One of the major challenges, the large area under degraded land. Maximum area of the India is suffered by the water erosion, that is about 18%. Then soil fertility declining in about 16% of the total agricultural land of the country. Wind erosion is affecting for the 60%, 6% of the land. Salinization, 4%, water logging and lowering water table is also very important challenge for the agriculture. Now, agriculture, for agriculture, weather and climate services are very important because increasing frequency of the extreme event is affecting drought, flood, cyclone, hailstorm, and cold waves, and their subsequent impacts on the crop production, crop phenology, livestock production, and livestock biomass, monsoon variability in terms of the erratic onset, monsoon break, early withdrawal, and decreasing number of the rainy days. High rainfall intensity is causing flood, uh, runoff, and making soil erosion. Similarly, water usage and groundwater depletion due to erratic rainfall and over extraction are also a very common challenge in India, especially in the southwest and northwest part of the country. Pest and disease dynamics are very dynamic, and they are very tolerant to different type of the climate, and their phenology, their cycling is fast changing. Their adaptive capacity is very high because of the changes in the climate. Their population is generating more faster than the previous. Vulnerability of small and marginal farmers, low adaptive capacity, and high exposure of the weather shocks are making farmers more vulnerable to the any changes in the climate system. This is latest study showing the India's hotspot of the climate change. In India, between 2015 to 2024, about 0.89 degrees centigrade temperature has been increased related to the 1901 to 1930 period, and it is more cause of worry that warming is more projected about 1.2 to 1.3 degrees centigrade by the mid of the century. Since 1950, tropical Indian Ocean has warmed about 0.12 degrees centigrade per decade, and SST 2.45 climate projections has warned that about 0.13 degrees centigrade temperature will be increased by the year 2100. Heat waves are projected to rise from 20 days per year during 1970 to 2000, but now these are expected to be nearly 200 days per year by the mid-century. So heat waves and warm nights are expected to be more. At 1.5 to 2 degrees centigrade warming levels by 2100, the glacier warming may decrease by 30 to 50%. This is very big challenge for the coastal agriculture. Similarly, for the rainfall, southwest rainfall has been declined by 0.5 to 1.5 millimeter per day per decade over the Indo-Gangetic plains and northeast India during 1951 to 2024. However, models projected about 6 to 8% increase in all India mean southwest rainfall by mid-century relative to recent past. But spatial variability is very much. Pre-monsoon cyclone intensity in Arabian Sea has been increased by 40% over 1982 to 2019. Sea level in the North Indian Ocean have increased by 3.3 millimeter per year, with extreme sea level events increased by 2 to 3 times. The WMO bulletin number 70 in 1373 has confirmed that last 11 years have been the warmest years on the record. Temporary cooling by the La Nina does not reverse the long-term trend, means warming is still continued. Ocean warming continues. Now Asia is much vulnerable because Asia is currently warming nearly twice as fast as the global average, with the 1991 to 2024 trend almost double compared to 1961 and 1990. In 2024, Asia's average temperature was 1.0 degrees centigrade higher than the 1991 to 2020 average, ranking as the warmest or second warmest year on record. Climate change exhibits extreme events which pose serious threats to agriculture, and agriculture is source and victim of the climate change. Source in terms of the releasing GHG into the atmosphere, and victim because it is also suffering from the impacts of the climate change. In January, according to January 2025, according to Copernicus Climate Change Services, year 2024 was the warmest year since record, with an average global surface temperature reaching 1.6 degrees centigrade above pre-industrial level, surpassing for the first time the 1.5 degrees centigrade warming target set by the Paris Agreement. The Paris Agreement, upper limit set by the Paris Agreement, we have already exceeded. Notably, year 2024 was the second consecutive year with the hottest global temperature, surpassing 2023 by 0.12 degrees centigrade. Before 2024, year 2023 was considered as the warmest year, but 2024 has been surpassed the 2023. Now the situation in 2025, global average temperature in 2025 was 14.9 degrees centigrade, 14.97 degrees centigrade. That is 0.59 degrees centigrade above 1991 to 2020. Average 1.13 degrees centigrade below 2024, warmest year on the record. Air temperature above global land areas was second warmest, 0.2 degrees centigrade cooler than 2024 and 0.01 degrees centigrade above 2023. Global sea surface temperature was 20.7 degrees centigrade and third warmest after 2024 and 2023. January 2025 was globally the warmest January on the record. March, April, and May were each of the second warmest for the first time. Earth's average temperature for January to August 2025 was 1.42 degrees centigrade with plus minus 0.12 degrees centigrade deviation above pre-industrial level. Each month of the 2025, except February and December, was warmer than the corresponding month in any year before 2023. So we are seeing that every successive years are more warmer than the previous years. Another study of the India IPCC stated that during 2000 to 2001 and 2000 to 2009, there was 0.9 degree centigrade increase in the global temperature. But after 2010 to 2020, that increase has been much accelerated and reached to 1.1 degree centigrade. So every decade are much more warmer than the previous decades. So this is the sorry, just 1 minute. Meeting. This is the climate change risk map of the world. Risk of climate change based on how much carbon dioxide is emitted annually indicates its contribution to climate change. There is a comparison between a given country's like to survive change against its responsibility for causing in the first place. Asia is more vulnerable because, as I already told that Asia is warming almost twice than the rest of the world. China is the global CO2 emitter, followed by United States, and India also ranked at the third for the GHG emission, CO2 emission. Russia and Japan are ranked at 4th and 5th. Iran, Germany, South Korea, Saudi Arabia, and Indonesia. These are also having large amount of the CO2 emission into the atmosphere. So this is climate vulnerability map of the country. Here we are seeing that CVI or climate vulnerability index is either low, moderate, or higher category, and estimated heat wave impacts in April 2022 using data from the India Meteorological Department shows that most of the places are in the coastal regions. They are highly vulnerable to the heat wave. Temperature anomaly is also another big challenge for the climate workers and agriculture. In India, there is a repeativity of the flood, drought, cyclones over year after year. Northern part of the country is high risky for the flood, medium risk for the drought, and low risk for the cyclone. Whereas southern part of the country is high risky for flood, high risky for the drought, and high risk for the cyclone. So southern part of the country is most vulnerable for all type of the extreme. So on the eastern part, northeastern part, western part, and the central part of the country is either belonging to low, medium, or high category of the flood, drought, and cyclone activities. Climate warming is affecting the hydrometeorological situation of the country, and hydrometeorological disasters have been very frequently observed in 35 states and territories. So, previous slides confirmed that the climate change is occurring with more pace and accelerations and affecting almost all the field related to the humankind. And these are the clippings of some newspapers related to climate crisis. There are different challenges and what are possible solutions. Challenges of rising temperatures and heat stress can be minimized with the heat adoption of heat tolerant and climate resilient varieties, adjustment in the sowing date, micro irrigation and evaporative cooling, mulching and canopy management, heat station early warning systems can reduce the risk of the rising temperature and heat stresses. Similarly, challenges of the pest and disease can be minimized through weather pest, weather-based pest and disease forewarning systems, applying the IPM strategies, integrated pest management system, crop rotation and diversification, surveillance and rapid response mechanism, capacity building of extension personnel. Small and marginal farmers' vulnerability can be reduced through farmer-centric advisories in the local language, what we are already issuing, strengthening extension and digital delivery platforms, integration of traditional knowledge with the scientific forecast system. Now, increasing frequency of the extreme events, its impacts can be reduced through early warning system and impact-based advisories, which has now India has started the impact-based forecast and advisory systems, crop diversification and integrated farming system, weather index, crop insurance and risk transfer tools can be some positive solutions for extreme events. Monsoon variability can be addressed with the weather-based dynamic sowing window. Use of the short duration variety, drought tolerant varieties, contingency crop planning, moisture conservation and drainage management systems, real-time advisories can be solution options. Subsequently, water stress and groundwater depletion can be addressed through precision irrigation using drip and sprinkler methods. Means we have to increase the efficiency of the irrigation systems. We have to avoid the wastage of the water, and we have to provide the precise need-based water to the crops. Crop diversification away from water-intensive crops. Climate-informed water budgeting at farm and water levels. Climate change is posing several types of threats because of the increase in the temperature. It is affecting water resources, pollutions, causing to the death of the humans, leading to economic loss about $2 to $4 billion, throwing lots of the vectors because their population is increasing, their cycle is reducing. So in a year, instead of 4 to 5 population cycles, now we are experiencing pest population cycle from 6 to 7 per year. So so agriculture is also affecting with the different type of the pest and disease problems. Our natural resources are very much threatened with the increase in the climate crisis. This is the situation of Punjab, where water is available up to a total 53.06 billion cubic meter through 14.8 billion cubic meters of fresh water available in the dams or canals. 26.3 billion cubic meters is receiving through rainfall. 1.26 billion cubic meter as treated water and 10.7 billion cubic meter of the return flow. So all these water sectors are accumulating total 53.06 billion cubic meter of the available water. But Punjab is extracting about 66.12 billion cubic meter water, that is 13.06 billion cubic meter additional water that is brought through 5.1 billion cubic meter from drawdown water and withdrawn from the deep aquifers about 7.96 billion cubic meters. So this is 13.06 billion cubic meter is actual gap between the demand and utilization. So this water is demanded by rural domestics 1.27 billion cubic meters. Urban domestics requires 1.14 billion cubic meters. Industrial demand of the state is 1.13 billion cubic meters. And agricultural demand is very high, 62.58 billion cubic meter. So if you see the 62.58 billion cubic meter of the agricultural water demand, that is all itself, it is very high than the available usable water of the state. But we are using 66.12 billion cubic meter of the fresh water, including 62.58 billion cubic meter for the agricultural irrigation. And surprisingly, rice alone consumes about 40 to 50% of this agriculture water demand. So alone rice crop is responsible for about half of the total water demand for the agriculture in the state of the Punjab. Therefore, we have to be very serious for this particular natural resource. And you see that at now India's irrigation efficiency is about 50%, 40%. Under 40% of the irrigation efficiency, Punjab state's water demand is about 62.6 billion cubic meter for the agriculture, but availability is only 53.1 billion cubic meter. So we have to use precision irrigation systems, micro irrigation systems, and if we are able to increase the irrigation efficiency from 40 to 60%, then our demand can be decreased much below the water that is available for irrigation. So what we are seeing that rice is responsible for almost 50% of the total water, and it is not only associated with the consumption of more irrigation water, but it has also several environmental threats, such as water required for puddling about 200 millimeter, and total crop water requirement is about 12 to 1400 millimeter. So a rice crop requires about 1400 to 1600 millimeter of the water throughout the crop cycle, including puddling and irrigation. Dr. Singh was stating that fertilizer consumption of the state is about 36% more than that is recommended. So depletion of the fertilizer, especially nitrogen in the form of the nitrate leaching into the soil, is contaminating the water and underground water. That is also a very big problem. chemical application is extreme in the Punjab. Punjab has only 2% of the total geographical area of the country, but its chemical consumption is about 17 to 19% of the total chemical required in the agriculture of the country. So, similarly, another trade, Punjab utilize heavy machinery for agricultural operations. So, energy requirement is very high. At the same time, crop burning is another big challenge for the Punjab agriculture because Kharif crops burning is very high in Punjab as compared to the other parts of the country. So, what is our role? What we can do as an agrometologist, as an agromet advisor, as a climate service, as a natural resource conservator? So here, if accurate information is already available with us in the form of weather forecast, and by utilizing accurate weather forecast system, we are able to just save only one irrigation for irrigation. So it will be able to reduce about 2.43 billion cubic meter of water for means this gap of 13.06 billion cubic meter can be reduced if we can save at least one irrigation by each crop. So this is our role where we can act, come forward and act. So this is another picture representing the effects of climate change on morphophysiological and biochemical changes in the plant. Already Surendra Singh sir have discussed some part, it's in his lecture, but I will try to explore. Climate change is especially in the form of increase in the CO2 level and subsequent increase in the temperature. Increase in the CO2 is increasing morphological changes, physiological changes, and biological changes. Morphological changes of the plant are larger leaf area, increase in the yield, stomatal conductance, increased plant biomass, increased shoot root ratio. So benefit of the CO2 enrichment in the plant is appearing in the morphological changes. Physiological changes includes increase in the photosynthesis system and viscous activity, but decrease in the photorespiration and transpiration rate. Likewise, biochemical changes include some increase in the phenolics, alkaloids, terpenoids. So accumulation of secondary metabolic system is increasing with increase in the CO2 level. On the other hand, when temperature is increasing, it is creating drought stress, leading to heat stress, increase in the metabolic production, high photorespiration. But when CO2 is increased along with the high temperature, its effects may be increased photosynthetic rate, heat and drought stress, elevated production of PSMs, and increase in the drought, heat, and pest stresses on the crop, and overall reduced yield and productivity. This is a picture of the effects of climate change and abiotic stresses on fruit crops. When sunburn is noticed in the citrus, blossom and rot in tomatoes, fruit cracking in different fruits because of the low moisture, rind puffing in the citrus, high temperature effects on the grapes, heat waves increase the diseases in the pears. So lots of the negative impacts have been noticed with the increase in the climate change in different crops. So this is the case study for which we collected IMD graded data, not graded data. IMD observed stations data from 1951 to 2025, and we tried to explore some agroclimatic indices related to extreme events at different agroclimatic zones. As per ICR, there are 15 agroclimatic zones, but one agroclimatic zone, zone number 15, that is Iceland region, that has there are no grid point faults in that region. That's why it has been excluded. And this is the data availability systems available data from and up to the year 2025. These are the crops of the being cultivated in particular agroclimatic regions, and this is the climate type related to the particular agroclimatic zone. So this is the summary. We have communicated it to the agriculture and forest meteorology just yesterday only. Here we are seeing that the Tx means maximum of the maximum temperature. So maximum of the maximum temperature means maximum temperature are increasing and decreasing, where negative sign indicates decreasing trend, and positive signs no signs means increasing trend is observed in so what we are seeing that lots of the agroclimatic regions except region 1 and region 2 to 7 are experiencing higher temperature than the decreasing trend of the temperature. So what another thing is observed that increasing rate is more than that is decreasing rate in another region. Similarly, tropical nights mean nights that have a temperature of above 20 degrees centigrade. These are also increasing in many regions except the 3 agroclimatic regions of the country. Surprisingly, about temperature of the 90 percentile is increasing in all the agroclimatic regions. No region has decreasing trend of this climatic index. DTR, diurnal temperature range, is decreasing for most of the region, but increasing in the 4 agroclimatic zones. Similarly, what we have experienced that agroclimatic indices are not common in all regions. Some regions is either having decreasing trend and some region has increasing trend. So based on this index, we can develop our advisory systems. We can mind it during the preparation of the agro advisory bulletins at different regions. And finally, what is conclusion of this finding is the western region recorded the highest tropical nights in the domain, and unexpected result revealing the greenhouse gas forced nocturnal warming and rising tropospheric water vapor are overriding the historically large diurnal amplitude of the Thar desert climate. Agroclimatic zone 14, that is Western Plain region, has recorded strong negative DTR, means narrowing the length of the diurnal temperature range, and the highest maximum of the maximum temperature means climate warming. It is indicating that perlimillet and livestock system of the western Rajasthan are going to be severely affected by this type of climate. East Coast plain and West Coast plains and Ghats record the second and third highest tropical nights trend alongside the largest maximum temperature increase in the domain. DTR is narrowing. It indicates that asymmetric nocturnal warming is now detected in 8 zones. Significant negative maximum of the maximum temperature trends has been recorded in agroclimatic zone 4, middle Gangetic plain and upper Gangetic plain. So ultimately, what is impact of this indices? Now, when temperature is shifting, ultimately our rigidity accumulation by the Rabi crops and by the Kharif crops is altering. Based on that, phenological duration is affecting, and overall conclusion is that climate warming is reducing the yields in many regions for both crop season, whether it is in Rabi and whether it is in Kharif. Both agricultural season productivity is being decreased. So this is another exercise which can be done with the use of crop weather information. So these are the stress indices can be calculated for the study regions. So now we have information on the climate. Now we have information of the extreme events. So how we can integrate our information, available information into the Agromet advisory bulletins. So already it has been discussed that the India Meteorological Department has now running the Gramin Krishi Mausam Seva scheme on its 130 agrometeorological field units, and it has been subsequently gradually changed the name from IAS to AAS, then GKMS. We were very fortunate enough that we had block level agro advisory systems under DAMUs. So this was the example for the world by the India. So under GKMS, we have very vast network of the Agromet field units. In Punjab, we had 5 agroclimatic regions and 5 MFUs. Like Surendra also telling that Hisar is leading for the 5 MFUs in the Haryana state. So functionality of the Gramin Krishi Mausam Seva, where I have served for the 10 years, and Surendra Singh sir has worked almost whole of his service in that system, initiated by Chattopadhyay sir, who has also developed this system very strongly and implemented GKMS in the country very effectively. So already this slide has been discussed by Surendra Singh sir. that IMD we need to develop weather forecast based on the weather forecast is based on the certain type of input data. That input data is being modeled and another model has been generated that is provided to the MFUs at the districts to develop district level agro advisories, and these advisories are being disseminated with the use of the district extension services like CB Gyan Kendra. Dr. Surendra Singh has very elaborately explained this by utilizing the agriculture officers, agriculture development officers, horticulture development officers, total agricultural systems of the district. Sometimes we also communicate it through the email, through WhatsApp, through social media, newspapers, radios, and finally, when it is disseminated, after that we have mechanism of the feedback collection. That is very important. Feedback collections, whether farmer or user of our bulletin has been benefited or incurred some loss due to advisory system is also very important. So if one wants to see the agroclimatic situations, if he wants to know the Agromet products of the country, of his region, so he must visit the Agromet portal of the India Meteorological Department. Here various types of Agromet products, like satellite products, weather parameters, soil temperature, soil moisture. So lots of Agromet related parameters are available on the website that can be look forward. Here in the Agromet portal, features available on the Agromet website is Agromet advisory system bulletins, weather forecast, observed weather data, Agromet products, advisory status, block level, district level, and state composite advisories, farmers awareness program, success stories, special advisories. Means if a farmer or any region not received advisory, he must be aware through the awareness programs that these are the sites, this is the sites from where you can get the information. Although we are trying to supply advisories to the each and every farmer through different social media, through different newspapers and mass media channels, but in any case, if some farmer is not getting advisories, then this is the methodology, this is the way by which he or she can be obtain the advisory of his region. Similarly, in that portal, Agromet portal, there is standard precipitation index, there is weekly aridity maps. Based on that, he or she can know the situation of the rainfall, soil moisture, and aridity of his respective region. Chattopadhyay sir already explained about the various types of weather forecast, nowcasting, short range weather forecast, medium range weather forecast, long range weather forecast, extended range weather forecast, and their lead time and their possible applications in the agriculture section. So I will not much spend time on it. In Agromet advisory bulletin, what are different components? Different components are past weather conditions, means in previous week or in last 5 days, what was the situation of the rainfall occurred or not occurred, what was the situation of temperatures, maximum, what was the level of maximum temperature, minimum temperature, humidity, wind speed, wind direction, and what is the forecasted weather. Means we have to look the past weather also, and we have to look the forecast weather also. Forecasted weather for next 5 days. What we are using in our Agromet, routine Agromet advisory system on every Tuesday and Friday, we have 5 day weather forecast. So once we have 5 day past weather data and 5 day previous weather data, based on that, depending upon the crop stage, we can make decision related to agricultural operations. For an example, if in last month there was a rainfall, and in current month, current week there is no forecast for the rainfall, so we can understand that if sufficient rainfall has been occurred in the previous week, there is no need to give irrigation. Conversely, if we say that last week was the dry and current week has some amount of rain forecast, so we can advise the farmer that please don't irrigate, otherwise your precious water inputs, your labors, all resources may go waste. So main components are previous 5 day weather situation, previous week weather situation, and coming week or coming 5 days weather situation, and concurrent crop phenological stages. Phenological stages are also very important, that water requirement or input requirement or climate related stresses are different at different crop growth stages, and adaptive capacity and reacting capacity of the plant to those stresses are different at different phenological stages. So for an agrometallurgist who is going to prepare agromet advisory bulletin, it is important to know the previous weather, past forecast weather, crop phenology, and he must know the existing sowing windows, crop water requirement, nutrition status, and what are the major pest and disease problem of that region. So by integrating these components into a bulletin, we are preparing on every Tuesday and Friday and disseminating it through different mass media. So past weather, see the situation of the past weather, and this is the forecasted weather. Once received forecast, and once we analyze the past weather situations at our MFU level, we have organized or arranged one Agromet advisory board, including different scientists of different sectors like agronomist, animal scientist, entomologist, pathologist, breeders, different experts related to the agriculture are found in a board, and after receiving the weather forecast is being discussed with the member of the advisory committee, and based on their recommendations, the inputs in the agricultural inputs are provided based on the crop specific stages, and these are disseminated. So this is an example of the Agromet advisory which has been prepared at MFU Faridkot. See past forecast weather situation, past weather summary, and weather warning, if any. What is the likely impact of forecast and warnings on the crop? What is the general advisory? And what is the short advisory, impactful and advisory you want to disseminate to the farmer in the form of SMS? And what is the extended advisory systems? So these are two different set of the Agromet advisory bulletin. Once we have disseminated advisory either on Tuesday or Friday, there may be a abrupt change in the system, and under those situations we have to inform the farmers that such and such situation are going to be happen, and this may harm your livestock, your crop, and so you can take appropriate decision for it. So what is alternative for that? We have created different social media groups. Earlier M-Kisan portal was working. Now different universities have developed their own systems for dissemination, and we are sending direct SMS alert to the farmers' mobile, indicating that this is the situation and take appropriate action. So this is the comparison of the weather forecast with actual weather data, monthly forecast average, or total of the monthly forecast and monthly observed weather data situation of the southwestern Punjab region, Faridkot, 2024-25. So what we are seeing that the temperature forecast is all very good in all months. Rainfall forecast, particularly in the July, August, and September during 2025, has shown large deviation. Similarly, humidity has much difference. Wind speed is closer, but cloud forecast wind speed is closer, but cloud forecast is again has very wide association between observed and forecasted weather. So weather accuracy is very important. Weather forecast accuracy is very important because we are preparing our advisories based on the forecast. If forecast is correct, our advisory is correct. If forecast goes wrong, our advisory may go wrong. So this is the system of Agromet advisory generation. We have 700 districts are issuing district level forecast. State 30 advisories are being issued at the state level, and one national Agromet advisory bulletin is being prepared by the Indian Meteorological Department on every Friday. And these are the disseminated by different Agromet field units extended over 130 locations of the country. Another forecast is impact based forecast. When this forecast is particularly useful to reduce the risk of extreme weathers. When regional meteorological center or meteorological centers of the Indian Meteorological Department are issuing impact based forecast or IBF, at the same time, at the same day, MFUs are triggered to prepare one bulletin, short bulletin for the farmers to tackle the negative impact which may be due to this abrupt weather or extreme weather situation. So this is the dissemination. This is very important component of the advisory system. You have prepared advisories, but until or unless it is not reaches to the end user, to the users, it has no use. So advisories must reach to the farmers at appropriate lead time. So these are the different ways what we are using for the dissemination of the Agromet advisory systems already has been discussed by our previous speakers. So not posing much time on it, we are simply skipping. Now this is very good thing for the agrometologist that news channels, especially TV programs, are being prepared, and our agrometologists are being invited by the TV channels, and they are very discussing. See, this is program where Kheti Mausam Se Mama. This was the topic given to me by the DD News, and when we joined our services, Surendra Singh sir mentioned it that it was very hard to convince a newspaper, TV channel to give a place to our information for publishing. But nowadays, channels, newspapers are themselves coming to us. And is there any important information for the dissemination? We are ready to disseminate it. We are ready to timely disseminate it. So, based on the timely forecast, based on the timely bulletin preparation and timely dissemination through different mass media, we have successfully addressed different extreme events and cyclones activities in the coastal areas, and we have reduced the losses what was expected from these events, and we saved lots of resources, lots of monies, and lots of lives. So this is importance of our system, that it must be extended and it must be strengthened at a micro level. So this is another program which is being disseminated at Krushi Darshan program of the DD Sahyadri in Marathi. This is the way of newspapers from which important key points are being placed in the newspapers, and these are being published by the newspapers. Chattopadhyay sir already mentioned that we have different important mobile apps that are very useful for the common people, and among them Mausam is one of them, Domini, Meghdut. So through all these mobile apps, we are sending information, useful information to the peoples, and in Meghdut app, farmers can directly download the Agromet advisory in their own language of their region. Different universities and institutes have developed their own centers and own methodology for the dissemination. This is the WhatsApp messages being transmitted from all over India. This is another Panchayat Mausam Seva, because we feel that the village to village variability in the climate systems have been noticed. So to monitor, to address that variability, now Panchayat Mausam Seva has been launched on the 15th January 2024. This is another picture of the Gram Panchayat level weather forecast system. This is farmers feedback on Agromet advisory bulletin. This is very important section for the agrometallurgist that until or unless you are not being told your strength and weakness by the users, our chances of the improvement may be limited. So on September 10 and March 11, we collected farmer feedback from 95 and 10 farmers respectively, total 180 farmers, 185 farmers, and this is the category of the rating given by the farmers for our advisory systems. So this is very quite satisfactory and encouraging to see the number in the excellent, good and satisfactory level. This is awareness program feedback what has been earlier discussed. At Punjab Agriculture University, we have developed PAU Kisan app, and sir, in PAU Kisan app, we have registered nearly 11 lakhs farmers, and total farmers of the Punjab is around 16 lakhs. So among 16 lakh, we have registered for the 15 lakh, 11 lakh of the farmers. So based on the availability of the weather forecast, this is the number of bulletins we have disseminated year-wise, and these are the number of important bulletins published in the newspapers based on the occurrence of the events, importance of the advisories, number of SMS sent through mobile SMS, and these are the farmers which are regularly being updated in the database of the university. These are the PAU publications. Kheti Sandesh, it is very important publication which is being utilized by the farmers, and it has compulsorily published the weather forecast of all the 5 agroclimatic zones, all the 5 MFUs of the state on the front page of the Sandesh paper. So now we are also demanding the articles related to the agriculture from different extension workers, scientists, researchers, and academicians, and we are placing in the Kheti Sandesh either in the Punjabi version or English version. These are another important publications available for the farmers at the PAU website, free of cost, free to download, and interested farmers visit PAU website and download the publication of their use. So ultimately, why weather forecast? Why weather based agromet advisory bulletins? What are their economic impact? One, National Center for Applied Economic Research, NCAER, New Delhi, conducted research in year 2019 by interviewing 3,965 farmers across 121 districts of the 11 states of the country, and they reported 98% of the surveyed farmers made modification to at least one of the 9 practices based on the weather advisories. Average annual income of the surveyed farmers was rupees 2.43 lakh with modification in 1 to 4 practices. We advised 9 practices, and if farmers are adopting 1 to 9 practices, they can get 2.43 lakh rupees, and if farmers adopt 5 to 8 practices, it may be he or she may be benefited up to 2.48 lakh rupees. If a farmer adopts all the 9 practices, he may get rupees 3.02 lakh rupees. And if any farmer is not adopting any of the advisories disseminated or given by the MFUs or the agrometallurgist, so he may receive only 1.8 lakh rupees. So 80% of the farmers receiving information on high resolution weather events reported to have reduced losses. So this is important of the weather-based agromet advisory bulletins for the farmers, for the state and for the nation. Similar impacts had been also noticed by the livestock farmers. They have surveyed the livestock farmers based on the 3 practices: modification of shelters, vaccination against season disease, and fodder management. 18% of whom are doing so on 2 practices, and 6% are doing so on 1 practices. 96% farmers reported that weather advisories are improving the practices of vaccination against seasonal livestock diseases. These are the another impact of the method of the impact analysis of the agromet advisory services. These are being translated into operational practices in the form of the scientific literatures through research papers, in addition of the extension bulletins. So lots of the experiments have been conducted to include weather forecast and weather-based information systems to mitigate the negative effects of climate change, for the resource conservations, to enhance the productivity and profitability of the farmers. So at last, these are some of the challenges what are being faced for the effective dissemination and preparation of the agromet advisory bulletins. Main is accuracy and reliability of the weather forecast and warnings. Although we have received very good accuracy nowadays, one example has been already given by Upadhyay sir for the year 2016. But still, there are sufficient scope to improve the weather forecast accuracy. And weather forecast accuracy can be improved by the increasing the network of the observatories nowadays, which is very dispersed across the country. And agricultural complex nature of the country, effective coordination between stakeholders, state government officials, block level agriculture officers, ICAR scientists, state agriculture universities and research institutions. Unavailability of the location specific thresholds for weather variables and their impacts in quantified way for all the districts. Subjective nature of the advisories depending on the knowledge and expertise of the staff posted there. It is I think this is not appropriate place to discuss that the permanent nature of the temporary nature of the officials engaged in the FUs. They get trainings, they learn, they start working and they shift to another job. This is one of the major challenge. Implementation of the robust monitoring and evaluation system, enhancing the outreach of the maximum number of farmers, engaging farming communities in the development and refinement of the advisory system. Surendra Singh sir has already discussed that the IMD has given one platform to put the local informations on the national portal. Low education level and technological inefficiency of the farming community, and at last, inadequate infrastructure are among the some of the major challenges related to the effective dissemination, preparation, and application of the Agromet advisory bulletin in the operational use of farmers. Thank you so much. Thank you for giving opportunity me to discuss with you all, and thank you for the questions listening.
Namaste, sir. We're hearing some echo.
Yes, some work.
There's some echo is going on, sir.
Yeah,
Some,
they have some work.
some disturbance or echo is coming. Someone has something else. So kindly mute their system. You carry on, sir. Yes, thank you, sir. The for participant, they are really eager to learn more things. The basic issue is they have to be very keen, to be very interactive. You can contact us, you can contact all stakeholders, and we will be ready to help in all forms of agrometeorology. So don't be shy, make their questions available and fire on us. We are with you. We are also learning from your region, your issues, and we all here to solve all this. Thank you. Over to Sudhir.
Yes, thank you, sir. Most of the participants are all up to the age of me, same age, and almost have similar type of experience. So there is no hesitation to me to speak before them. Uh, as sir, you told that we have to make a strong collaboration, strong networks among us. So there are different capacities, capabilities of different participants. Someone maybe have very good skill in the writing, some have very good idea. As a senior person, so you can give very good idea and we can work. Someone has very good skill for the analysis, writing skills. So when we do collectively for our same purpose, we can increase the productivity and we can address many of the challenges related to the climate important for the agriculture. So as of now, I am ready if someone has any project, any work in his mind to collaborate us. So at my own level, I will try to also get uh, clearance from the institutes also to collaborate and involve also to the peoples if someone is interested to work with us.
Okay, thank you, sir.
Thank you, sir. Thank you, everyone.
Yeah,
Thank you,
bye-bye.
sir.
Thank you.
Thank you.